All right, so we know what polynomials are. We've added, subtracted them. We've put them in standard form. We've multiplied by a monomial, and then we multiply two binomials together. Today's assignment, though, we're going to be extending that idea of multiplying polynomials and multiply binomials with trinomials. So let's go ahead and start with just a little bit of a review from our last unit, things that we're going to need to know when we do what we're going to be doing today. I want you to pause the video and just complete these three problems and see if you can remember what happens when you take x to the third plus x to the third, and then x to the third times x to the third, and then x to the third, because they're all different. So pause the video and complete those, and then we'll move forward. Hopefully this is what you have done. If I have 1x to the third plus 1x to the third, that's 2x to the thirds. So when I add like bases, I can only add them if they're identical to each other. Now I can multiply x to the third times x to the third, but when I do that, I add the exponents, because that means this is x times x times x times another x times x times x. This is x to the sixth, because when I multiply like bases, I add the exponents. But then number 3, if I have x to the third, that means I have 3x to the thirds. And so if I have 3x to the thirds, that means I have 3 here, and 3 here. So altogether, that's x to the ninth. And if you remember correctly, when we take a power to a power, that means we multiply those two exponents together. And so number 3 is x to the ninth. So that's a good review for us before we start doing problems that look like this. So we want to multiply the following together. I'm going to take 4x plus 8 times this trinomial, x squared times 3x plus 9. And so we can draw a picture of what is going on here. Picture is going to be a little bit more complicated than the other pictures that we had. Here I would have 4x's and an 8. And here I'd have an x squared, a 3x, and a 9. Now we could break this down and go 9 individual parts and things like that, but I'm going to just break it down like this. And if I multiply these together, that means I want to find the area of what they would get if we took the length times the width. To find the area of this rectangle, I'm going to take 4x plus 8 times x squared plus 3x plus 9. And so I can do that in 6 different parts. I can first multiply 4x times x squared together to get the area of this rectangle. That's going to be 4x to the third. If I do the same thing by multiplying 4x times 3x, that's going to give me 12x squareds. This is still 4x, but times 9, that's going to give me 36x. So that's the top 3 rectangles. If I do the bottom 3 rectangles, this area right here is going to be 8 times x squared, which is 8x squared. Then I'm going to take 8 times 3x, which is 24x, to find the area of this rectangle. And then this bottom right rectangle is going to be 8 times 9, which is 72. So if I combine my like terms, I have one that is 4x to the third. I have these two x squareds. 8x squared plus 12x squared is 20x squared. 36x's plus 24x's. Well, that's a total of, 60x's. So 60x plus the 72. And so if I multiply those two things together, what my final answer is going to look like is 4x to the third plus 20x squared plus 60x plus 72. So can we do this without drawing the picture? And yeah, we can. We can use the same concept that we did before, like the double distributive property. I'm going to start by taking this 4x and distributing it by all 3 of these terms in the trinomial. 4x times x squared would be 4x squared. 4x times 3x would give me 12x. 4x times 9 would give me 36x. Notice that's the same thing that I have here in the top row. This is x squared. Then when I multiply the 8 out, I'm going to multiply it by all 3 of these terms as well. So 8 times x squared is 8x squared. 8 times 3x is 24x. And 8 times 9 is 72. And so notice that's the bottom row here. So when I combine like terms, this was x to the third, by the way. So when I combine like terms, I'll have my 4x to the third. I'll have 12x squared plus 8x squared, which is 20x squared. I have 36x plus 24x, which is 60x, plus my 72. And so you can see I can do this by just using the distributive property, like the double distributive property. Let's see how this applies to something like this. I'm going to start by I want you to pause the video and try this on your own, and then you can restart it. When I multiply these together, I'm going to start with 7x times 5x squared. That's 35x to the third. Then I could take 7x times negative 4x, which is negative 28x squared. And then 7x times negative 3 is negative 21x. If I take the 2 and multiply it out, it's going to be 2 times 5x squared is 10x squared. 2 times negative 4x is negative 8x. And 2 times negative 3 is negative 6. So if I combine like terms, I have my 35x to the third. Then I have negative 28 and negative 21 is going to be negative 39x squareds. Oops, this is not an x squared here. I have an x squared here and an x squared here. So let me erase what I did wrong there. I'm going to have negative 28x squared plus 10x squared is negative 18x squared. And then I have a negative 21x and a negative 8x. Well, that's a negative 29x. And then my minus 6. And what I want us to see is that whether I write it like this or like this, I could put the 5x squared minus 4x minus 3 first, and then the 7x minus 2. And I could just simply distribute the 7x times these three terms this way, and then the 2x times those three terms. Or I would get the same thing if I multiplied the 5x squared by both of the terms, and then the negative 4x times both of these terms, and then the negative 3 times both of these terms. So it doesn't matter what factor I have first when I multiply them together. As long as I multiply every factor here by every factor here, I would end up with the same answer. And so let's go ahead and move on to the last problem we have here. I want to find the area of the shaded region. And so the shaded region is all of this area, but not the white rectangle. So what I'm going to do first is find the area of the triangle. You might remember that the area of a triangle is 1/2 the base times the height. So to find the area of the triangle, I would take 1/2 times the base, and the base of the triangle is 8x plus 12. And then the height of the triangle is 2x plus 5. So I'm going to multiply these three things together first, and it doesn't matter what I multiply together first. I have three things here. I have the 1/2, I have the 8x plus 12, and I have the 2x plus 5. I can multiply the 8x plus 12 times the 2x plus 5 and get that answer and times it by 1/2. Or what I'm going to do is multiply the 1/2 out first. 1/2 times 8x is 4x, and 1/2 times 12 is 6. And there's my answer when I multiply those two factors out, and then I would multiply that by 2x plus 5. So now I'm going to FOIL. 4x times 2x is 8x squared. 4x times 5 is 20x. 6 times 2x is 12x. And 6 times 5 is 30. So the area of the whole rectangle can be simplified, or whole triangle can be simplified to 8x squared plus 20x plus 12x is 32x plus 30. Now, that is the area of the whole rectangle. But I'm going to have to subtract the area of this white rectangle here, the whole triangle. This is the area of the whole triangle. But I don't want the area of the whole triangle. I want to get rid of this rectangle. So I'm going to have to find the area of the rectangle. And to do that, I'm going to take its length, which is 3x minus 1, times its width, which is x plus 2. So when I do that, I'm going to FOIL. 3x times x is 3x squared. 3x times 2 is 6x. Negative 1 times x is negative x. And negative 1 times 2 is negative 2. And so my final area of the white rectangle is 3x squared. 6x minus x is 5x minus 2. So then what I want to do is take the area of the triangle and subtract. I'm going to take this and I'm going to subtract the area of the rectangle, which is 3x squared minus 5x minus 2. So what I'm going to do is multiply everything here by negative 1. So instead of a positive 3x squared, I'll have a negative 3x squared. Negative 1 times 5x is negative 5x. And negative 1 times negative 2 is positive 2. And now if I combine like terms, I have 8x squared minus 3x squared, which is 5x squared. 32x minus 5x is 27x. And 30 plus 2 is 32. So the area of the shaded region, which is the area of the triangle minus the rectangle, is 5x squared plus 27x plus 32. That's what our homework assignment is about, and we will work hard on that and come back together in class tomorrow and go over questions. We'll see you then.